Welcome student. Numerical. Two coils made of same material. Made of same material. That means resistivity of the first coil is equal to resistivity of the second coil, or we can say the resistivity of the coil is equal to rho. Connected in parallel, these two coils, coil number 1, coil number 2, connected in parallel across the mains, across these mains. The length and diameter of one coil, see coil number 1, length of coil number 1 is, call it a L1, and diameter of coil number 1 as D2 is one coil is triple of that other, that is L2 is equal to 3 times of L1 is equal to 3L, because L1 is equal to L, and D2 is equal to 3 times of D1 is equal to 3D. And we know it is made out of same material. Same material means both will have same resistivity, as that we have written already. Correct? Okay. Which of these will produce more heat? More heat. This is more heat. See, as it is, we know heat produced is equal to power into time, that is energy. Energy means heat energy is equal to V into I power into T. Therefore, heat energy produced is equal to V. This, if we replace for I V by R, this will become V square by R into T. Now we have to find out which one will produce more heat. So H1 we can write. What is H1? H1 is equal to V1. V1, because both are connected to the same source in parallel, V1 square by R1 into T. See, T1 is equal to T2 is equal to T. Why? The current will be passed. The current will be passed in this coil as well as this coil at the same time, so that we can find out which coil is producing more heat in a given time. So T1 is equal to T2 is equal to 0. And H2, what is H2? H2 is equal to common potential divided by resistance of the coil 2 into time. So we have to compare these two. It means we can write H2 by H1 is equal to V square R1T divided by V square R2 into T. This get cancelled, this get cancelled. Therefore, H1 by H2 by H1 is equal to H2 by H1 is equal to R1 by R2. Now we have to find out R1. See, R1, see what is the resistance? The general formula resistance is equal to rho into resistivity into A into L. Here the diameter is given. Diameter is given, it means rho L area is equal to pi R square, or we can write resistance is equal to rho L divided by pi. Since diameter is given, we will write d by 2 whole square. So d by 2 whole square. So R1 by R2. So from here, rho for the 1, R1 by R2 is equal to rho 1, which is rho into L1. What is L1 is equal to L divided by, this is pi by 4 into d square. Pi by 4 into d square for this first one. R2, what is R2? R1 by R2. Rho into L2. R2 is equal to L2. What is L2? L2 is equal to 3 times of L into 3 times of L divided by pi by 4 into for to D2. D2 is equal to 3 times of D. 3 times of D. So we can cancel the common term. These and these get cancelled. these two get cancelled, and these get cancelled. Sorry, 3d into pi, because pi by 4 d square, d2 square, d2 is equal to 3 times of d, because d2 is equal to 3 times of d. So this also we can cancel, this which is become rho L. This is what is left out. This d and this d can be cancelled. This is equal to, this 9 will go, 9 by 3 is equal to 3. Therefore, sorry, this is H2 by H1, H2 by H1, R1 by R2, R1 by R2 is equal to H2 by H1. So we can write H2 by H1, or H2 is equal to 3 times of H1. That is, H2 is greater than H1. That is, heat produced by coil 2. Coil, it means nothing but a resistance, is more than coil 1. Two resistors R1 and R2 may be connected either in parallel or in series. First, let us see series. Two resistors connected in parallel or series to a battery. This is battery with zero internal resistance. It means it does not have internal resistance. Battery, we can write V equal to R, we can write like this, and R1 is equal to 100 ohm, and R2 we keep it as R. So since power in series is equal to V square divided by total net divided by R equivalent, that is V square divided by R equivalent, both are in series. So this will become R1 plus R2. And second one, the same thing is connected in parallel. This is R1, this is R2, connected in parallel to the same battery with zero internal resistance. So what is this equivalent? P in parallel, power in parallel circuit is equal to V square by R equivalent. Since it is parallel, so R equivalent, what is R equivalent? R equivalent in parallel is equal to multiplication of these two, R1 plus R2, R1 into R2 divided by R1 plus R2. So this is equal to V square divided by R1 into R2, divided means we can take it on the top, R1 plus R2. This is power, and it is also given, it is required that Joules heating for parallel combination will be 4 times. 4 times in series, parallel combination is 4 times of the series combination. That is heating. So heating of parallel is equal to 4 times of heating the combination in series. Or we can write this one, that is, what is heating? I, heat is given by H is equal to I square R into T. Because both are in the same time, for a given same time, it is given, because heat is always compared for a given same time for both the circuits. So we can write I square, that is I square R parallel into T is equal to I square, yes, this is I, this is I square R into R series into T. These two we can cancel, or I square is 4 times. This is 4 times. 4 times. So I square R parallel is equal to 4 times of I square R series. That is, power in parallel circuit is equal to power 4 times is equal to 4 times power in series. This is the condition we have got it. What is the power in series? So power in series is equal to power in parallel is equal to V square into R1 plus R2 divided by R1 R2 is equal to R1. This is the power in parallel, and power in series is equal to 4 times V square divided by R1 plus R2. So this we can cancel this and this. R1 plus R2 on cross multiplying is equal to 4 times R1 into R2. Expanding R1 square plus R2 square plus 2R1 R2 minus 4 R1 R2 is equal to 0. This becomes R1 square minus 2 R1 R2 plus R2 square is equal to 0. That is, R1 minus R2 whole square is equal to 0. Or this we can write, taking square root on both the side, R1 minus R2 is equal to 0. That implies R1 is equal to R2. Since R1 is equal to, R1 is given 100 ohm, that is R2 is equal to R1, that is 100 ohm. So in this condition, R1 and R2 both are 100 ohm for this given condition. If it is connected in parallel, if it is connected this condition is given is this one. Heat produced in the parallel combination of the same circuit with the same battery is equal to 4 times heat produced in the series combination. Under this condition, when both are of same resistance, it may be connected in series, it may be connected in parallel. In that condition, the heat produced in the parallel combination will be equal to 4 times the heat produced in the series combination. Find power supplied 10 volt battery, power consumed by 4 volt battery, power supply dissipated in 3 ohm. Given the circuit is this way. Since here you see the EMF of this one, E1, is greater than EMF of these two. That is, and moreover, it is in both are reverse connector. Reverse connected means this is more, the current will flow in this direction only, because this will give more current, it will give opposite current in the opposite direction, and the net current will flow here. So first we will find current. Current is equal to E net divided by the R, total resistance. Since here it is given no internal resistance, this is the only resistance. E net is equal to E1 plus minus of E2 because of the reverse polarity, divided by R. Therefore, I is equal to 10 plus minus 4 divided by 3 is equal to 6 by 3 is equal to 2 ampere. As it is, we know power is equal to voltage into current, R I square into R, or it can be written any form depending upon our convenience, depending upon the data given. So now this will give the power, this will give current in this direction. So this is supplying the power, and this is consuming in the form of heat dissipation. Heat dissipation means heat is evolving, power means heat dissipation through the resistance, and this also consumes its power. So it means we can say power supplied by 10 volt. Power supplied by 10 volt, we can simply write, we can use this equation, V into I, so is equal to, we can call it as a power 1. This is power 2. This is power 3. By 10 volt is equal to, is A P1, which is equal to V into I. What is the potential? Potential, this is its battery E1 into the E into I. Potential into current, that is here in place for battery we supply by the epsilon 1. So this is equal to 10 into 2 is equal to 20 watt. And power consumed by 4 volt battery, because it is supplying power, it is in the reverse direction, it will consume its power, and this will also consume its power. This is also equal to, we can write it as, we write it as P2, or P2 is equal to E2 into I, because power is equal to this expression for battery, instead of V it will come epsilon. So is equal to 4 into 2 is equal to 8 watt. 8 watt. It means after it supplies 20 watt, 8 watt it consumes, and remaining how much? 12, 20 minus 8. So let us calculate. Power consumed by (3 ohm) resistor. That is nothing but power consumed, means power dissipated in the form of heat in the resistor. This we can do, since we know, we call it as P3 is equal to, we can use this formula I square, or we can write V into I. Both will give the same answer. I is equal to 2 square into R 3. What is the voltage across this one? Voltage across the P3 is equal to, voltage across is equal to I into R, where I is equal to 2 ohm, 2 into 3, V into I, that is equal to 6 volt. Or we can do 3, that is 2 square, so 4 into 3 is equal to 12 watt. It means this consuming 12 watt, this giving 8 watt, and this is supplying 20 watt. So, or we can write P3, we can write in this also, P3 is equal to I square into R. I square as it is, we can use V into I. We can write what is potential across this one, V into I. V is equal to I into R. I into R into I. This is also giving 4 into 12 watt. So now we can see power is supplied by this battery, and this battery consumes its power, and this resistors also consume its power. So we can say, in simply we can say power supplied by 10 volt battery is equal to power consumed by 4 volt battery and 3 ohm resistor.